Good afternoon, student. Today we will discuss about the revision of the aldehyde and ketone. So in the last lecture I have explained about the preparation of aldehyde and preparation of ketones. Some method I have given how you will prepare aldehyde and ketone. Now today we will discuss about the chemical properties of aldehyde and ketone. Chemical properties of aldehyde and ketone. As you know, aldehyde and ketone both possess carbonyl group, single bond C, double bond O, single bond, like this. Aldehyde and ketones show many types of reaction. So first type of reaction which aldehyde and ketone can show, that is addition reaction. Addition reaction. Second type of reaction, elimination of water. Elimination of water. Third is reduction reaction. Fourth is oxidation reaction. Fifth is reaction involving alkyl group. And next are specific reaction. So we will discuss about the details of these reactions. First of all, going to explain the addition reaction. As you know, aldehyde or ketone both contain carbonyl group. This is aldehyde. It contains one hydrogen atom, and ketone, it contains no hydrogen. That's mean in both the bonds alkyl groups are present. When we show the addition reaction in aldehyde and ketone, so this carbon double bond oxygen change into single bond and nucleophilic addition will take place. That's mean nucleophile will attack at this carbonyl carbon. If you want to do the reaction of any substance which having nucleophile, so at that time addition will take place and that nucleophile will attack at the carbonyl carbon. Aldehyde show the nucleophilic addition reaction faster than ketone because of presence of one H atom at this carbon. Alkyl groups are electron repelling group. When these two groups are attached this carbon, so they increase the electron density at carbon. So carbon has more negative charge. That's why nucleophilic substitution will be slower in case of ketone. So I'm rubbing these things. I'm going to explain the addition reaction of aldehyde and ketones. So first is addition of chloroform. One number is addition of chloroform. Chloroform has the formula CHCl3. If we will write the structure, so we can write like this: HCCl3. This is the positive part and this is the negative part. That means CCl3 is the nucleophile and CCl3 will attack at the carbonyl carbon of aldehyde and ketone. So we have to write the reaction R single bond C single bond H double bond O plus CHCl3. So CCl3 will be attacked here and you will get R single bond C single bond CCl3 single bond H single bond OH. This H will be attached here and the bond between the carbon and oxygen will be converted into single bond. In case of aldehyde, this reaction will be faster and comparison to the ketone, but the reaction will be similar like aldehyde. I am writing the example for the ketone. R single bond C single bond R plus CHCl3. So you will get R single bond C single bond R single bond CCl3 single bond OH. All the aldehyde and all the ketones show this reaction. So you can write so many examples of aldehyde and ketone. I am writing some examples of addition reaction, that means addition of chloroform. So in place of aldehyde, if we take acetaldehyde, that means I am taking here CH3. So you will write CH3 single bond C single bond H double bond O plus CHCl3. You will get CH3 single bond C single bond H single bond OH single bond CCl3. What will be the name of this compound? This is carbon number 1, carbon number 2, carbon number 3. So 1,1,1 trichloropropane 2-ol. 1,1,1 trichloropropane 2-ol. Now see one more example. I am writing for the ketone. In case of ketone, you have to take both alkyl, aryl, similar or different groups. Suppose you are taking CH3 single bond C single bond C2H5. This is unsymmetrical ketone, double bond O. When we react with CHCl3, so you will get CH3 single bond C single bond C2H5 single bond CCl3 single bond OH. Now I am writing one more example for aromatic ketone. See, this is ring single bond C single bond CH3 double bond O plus CHCl3. It gives. So what you will get, students, see here, this H will be attached here and CCl3 at the carbonyl carbon. So you will get ring single bond C single bond CCl3 single bond CH3 single bond OH. You can write so many examples and very in easy method for all the aldehydes and all the ketones. Okay, students. Now the another addition reaction. This is the addition of chloroform on aldehyde and ketone. We can add so many compounds. I am writing some examples of addition reaction, out of which one is chloroform, another is hydrogen cyanide. Number 2, addition of hydrogen cyanide, HCN. This is also a nucleophilic addition reaction. As you are seeing hydrogen cyanide, hydrogen is positive and cyanide is negative. So negative part, that's mean nucleophile will be attacked at the carbonyl carbon. This is aldehyde, R single bond C, single bond H, double bond O. So addition reaction will take place, and hydrogen cyanide we are going to add cyano group, that means Cn negative will attack to this carbon, and H will be attack on oxygen. The bond between the carbon and oxygen will be converted into single bond. So reaction will be R single bond C, single bond H, single bond OH, single bond Cn. Similarly, the reaction we can write for the ketone. So in case of, I am writing the unsymmetrical ketone. What is the meaning of the unsymmetrical ketone? If the different alkyl groups are attached, R single bond C, single bond R dash, double bond O, and hydrogen cyanide will attack here. So this is the unsymmetrical ketone, because one is R, another is R dash. That means you can take here CH3 and here C2H5 or any other alkyl or aryl group. So you will write R single bond C, single bond R dash, single bond OH, single bond Cn. Dear student, you can write the reaction for formaldehyde, acetaldehyde, benzaldehyde, and similarly for ketone, acetone, propanone, butanone, acetophenone and benzophenone. So I am writing at least 2 examples, one for aldehyde and one for ketone. So for aldehyde I am taking here benzaldehyde, ring single bond C, single bond H, double bond O plus HCN. So you will get ring single bond C, single bond H, single bond OH, single bond Cn. This is the addition reaction of benzaldehyde and HCN. Now moving towards the addition reaction of benzophenone. This is an example of ketone group, ring single bond C, single bond ring. Both sides you are taking phenyl ring, double bond O plus HCN. So this is the positive part, this is negative part. Nucleophile will attack at this carbon and you will get ring single bond C, single bond ring, single bond Cn and single bond OH. This is the second addition reaction with aldehyde and ketone with hydrogen cyanide. Now moving towards the third reaction, addition of sodium bisulfite, NaHSO3. This is also an important reaction. By this reaction we can detect the ketone. The formula of sodium bisulfite is NaHSO3. In this, Na is positive and remaining part is negative. That means nucleophile is HSO3. So what we have to write when we will write the reaction, R single bond C, single bond H, double bond O. What is this, student? This is aldehyde. We can take formaldehyde, acetaldehyde, benzaldehyde or any other aldehyde On reaction with NaHSO3, you will get R single bond C, single bond H, single bond OH, and single bond SO3Na. You will get here like this. So, dear students, similarly, we can write the reaction for the ketone. I am writing first example of aldehyde. I am taking in this time formaldehyde. H single bond C, single bond S, single bond, double bond O. This is the first member of aldehyde family and it is called formaldehyde. In IUPAC system, it is called methanol. When it reacts with sodium bisulfite, NaHSO3, so you will get H single bond C, single bond H, single bond OH, single bond SO3Na. One example I am writing for the unsymmetrical ketone. I am taking butanone here, CH3, single bond CH2, single bond C, single bond CH3, double bond O. Why it is unsymmetrical ketone? Because you are seeing in this side we have taken CH3 and in this side we are taking 2 carbons chain, that is C2H5. So when it react NaHSO3, so you will get CH3, single bond CH2, single bond C, single bond CH3, single bond OH, and single bond SO3Na. Dear student, today I have explained about the addition of aldehyde and ketone with nucleophile. Now in the next lecture we will explain about the elimination reaction and remaining reaction. For today it is enough. Okay, goodbye.